Hey, Algebra 2B guys. Today we are going to solve polynomial inequalities. So let's take a look at the things that you need to make sure that you're doing when you solve them. So the big idea is that you've got to get everything on one side, and instead of having equals 0, you'll have greater than 0, greater than or equal to 0, less than 0, or less than or equal to 0. So just like when you solve equations, you have to have equals 0. Now, we're always trying to completely factor. So you completely factor using either traditional techniques like factoring a difference of squares, factoring a sum or a difference of cubes, using AC method, using grouping, or you might have to take it a little further and use the rational root test with synthetic division to get that factoring process started. Once it's completely factored, we're going to create a sign chart. So that's the new thing, is the sign chart piece. But once you understand them, they're extremely useful, but extremely quick. So here is an example that's already been worked out, and then we'll work some together, of how to solve a polynomial inequality. Now, linear inequalities that just have x to the first, you learn in Algebra 1. You don't have to change those. Polynomial inequalities are any that are x squareds, x cubes, x to the fourth, or higher. Well, look, in this equation, or an inequality, you have x times x plus 3 times x minus 4. This would be an x to the third problem if you multiplied it all out. So we've got to do a sign chart. Sign charts are necessary once it's x squared or higher. So instead of saying the answers are x equals 0, x equals -3, and x equals 4, instead we call those the critical values. The critical values are the numbers that we put on a number line. So I'm going to put -3, 0, and 4 on a number line in the correct order, left to right. Now what I do is I create a dividing bar between or below each critical value so that I begin to form a chart. And you're going to see this lots and lots throughout pre-calculus and calculus if you keep going with your math, and I hope you do. So now I say, all right, so I've got 1, 2, 3, 4 sections that I've created. Well, pick any test point that's in the first section. So any test point that would be to the left of -3 on the number line. Well, normally going big makes it go faster. So -10 or -20 would be a good one to pick. But you could pick -4 or -5. So between -3 and 0, if I think about a number on the number line between those, I might pick -1 or -2. If I think about a point on the number line between 0 and 4, I could pick 1 or 2 or 3. Now you can get crazy and pick fractions or decimals, but most people won't. Now pick a number on the number line to the right of 4. So I'm picking 15. Again, on the ends, if you pick big numbers, your sign chart tends to go faster. So now what you do is you plug these numbers into the 1, 2, 3 factors we had in factored form. So if I test -10, -10 going in for the x makes the first factor negative. -10 plus 3 going in right here makes that turn out negative. -10 minus 4 makes that turn out negative. And when I multiply 3 negatives, I get a big negative result. Now, I'll go over these others with you because it might be easier for you to follow along when I do them by hand with you. But recognize that I use all my signs and I get big results, a big negative, a big positive, a big negative, and a big positive. So I'll talk more about the sign chart with you on the next slide. But you go back now and you say, now what was it asking? So if it just asks you to do greater than or just less than, you have open circles, not closed circles. Now, you also have to go, well, greater than 0 means positive. So you're looking for this positive result and this positive result, and then we color the number line right there. Now all you've got left to do is give the interval solution for those places on the number line. So this would be parentheses -3 to 0, parentheses, and then union, because I've got another interval I need to say, parentheses 4 to infinity. Now we're going to do some by hand where I can explain more about the sign charts. Okay, so now we're going to solve the polynomial inequality x squared times x minus 1 times x plus 3 is less than 0. This one's already factored, so that means we're ready to name critical values and go into the sign chart. It's also, remember, it needs to have 0 on the right-hand side. It's there already. So I'm taking out some of the early work in order to help you just see the new part, which is the sign chart. Now, if I name the critical values, I'm going to say, well, x squared would give me a critical value at x equals 0. A lot of times we would say 0 is a double root, but that's not, we don't have to talk about double roots with critical values. X minus 1 tells me that 1 is a critical value, and x plus 3 tells me that -3 is a critical value. Now what I need to do is put these three numbers on a number line in the correct order. So I'm going to say -3 and then 0 and then 1. So I'm going to draw or make dividing bars below each one. And then I'm going to make my number line. Okay. So having 3 dividing bars gives me 1, 2, 3, 4 sections that I've got to test. So let me pick test points. So to the left of -3, I could pick something like -10. Between 0 and -3, I might pick -1 or -2 or -2.5 if I wanted to be more fancy. Now, between 0 and 1, I'm going to have to pick a decimal or a fraction, so I'll just pick 1/2. And then I need something that falls to the right of +1. Well, again, I could pick 2, 3, or I could pick 28. Okay, you can pick any test value you want to as long as it fits in that section of the number line. Now, I'm going to go through and I'm going to plug in up here. So when I plug in -10, I plug it into the first factor. -10 squared is +100. It's a sign chart, so I don't need the numbers. I just need signs. Then -10 minus 1 is -11. All I need is the negative. I don't need the numbers, so it makes this process roll faster. When I plug in -10 here, -10 plus 3 is a -7. Again, I don't need the number, just the signs. And if I multiply out an odd or an even number of negatives, it turns out positive. So I'm going to make my result sign really, really big. I'm going to do the same thing with -1. -1 squared is positive. -1 minus 1 would be -2. -1 plus 3 would be positive. And if I multiply out just one negative, the whole answer is going to turn out to be negative. When I plug in 1/2, 1/2 squared is positive. 1/2 minus 1 would be negative. 1/2 plus 3 would be positive. Oh, so I get a negative again. A lot of times your signs will dot back and forth, they'll alternate, but that's not a rule, so you always have to test. Plugging in 28, 28 squared is positive. 28 minus 1 is positive. 28 plus 3 is positive. When the numbers are big, it goes a little faster. And if you multiply out all positive numbers, you're going to get a positive answer. All right, so now look, it's less than, not less than or equal to. So that means that I'm going to do open circles. Now, less than 0, numbers less than 0 are negative numbers. So I'm asking you to pick out the negative results. So here's a negative result, color that part of the number line. Here's a negative result, color that part of the number line. So look, I see 1, 2 intervals that are separated by an open circle, so you can't lump them into one. If this was a closed circle, you could just say it was one big interval. But I'm going to say, okay, this interval is parentheses -3 to 0 parentheses, and then union, and I need to go parentheses 0 to 1 parentheses. So there is your first example. So we're going to do one more where it's factored already. And when it's factored already, go, whew, most of the work's been done already because the sign chart is actually the fast part. The factoring part is the part that takes time. But look, if I have a factor of 3x, then that just means that x would be 0. So I'm going to say I have a critical value at x equals 0. X plus 2 gives me an answer of -2. Normally, I would say since it's x plus 2 squared, it's a double root at -2, but you don't mention single, double, triple when you're doing critical values. So x minus 4 squared gives me a critical value at 4. So again, I've got 3 critical values. Let me build my sign chart. So on the number line, -2, and then 0, then 4 would be the right ordering. So I'm drawing my number line. Put a bar, a dividing bar below each one. Pick some test values. You'll notice that a lot of times I'll pick -10 and +10 on the outside edges. So what could I pick that's between 0 and -2 on the number line? I'd go with -1. And what could I pick between 0 and 4? Well, you could pick 1 or 2 or 3. Any of those are fine. You could be really wild and crazy and pick something like pi. I don't tend to be that adventurous. All right, so now we're going to plug in. So 3 times -10 would be -30. -10 plus 2 would be -8, but when you square it, it's going to be +64. Similar, -10 minus 4 is -14, but if you square -14, it's going to turn out positive. So one negative makes the whole answer turn out negative. When I plug in -1, 3 times -1 is -3. -1 plus 2 is 1. Squared is positive. And -1 minus 4 is -5, but when I square it, it's positive. So no sign change. Plug in 2. 3 times 2 is positive. 2 plus 2 is 4. Squared is positive. 2 minus 4 is -2, but when I square it, it's positive. So 3 positives gives us a positive result. Plug in 10. 3 times 10 is positive. 10 plus 2 is 12. Squared is positive. 10 minus 4 is 6. Squared is positive. So again, I have finished my sign chart. So now let's start to interpret results. So this time it's greater than or equal to. So or equal to means do closed circles. Okay? And it also says greater than. So greater than 0 means positive numbers. So I'll look here at my 2 positive results. So I'm going to color the number line. And look, on this one, it's not 2 separate intervals because 4 is colored in. So once I start with 0, I go forever to the right without the pause right here because that's a closed circle. So I'm going to say my final answer is bracket 0, and it goes forever and ever and ever straight through 4, so to infinity. All right, now we're going to look at some that have a little more meat to them. So now we're going to get into ones that take a little more time because you're going to have to factor first. So look, this is a quadratic inequality. So remember, if it's higher than linear, then this is the process you follow. The sign chart's necessary. So what you do is you say, well, it's all on the left with 0 on the right. That part's good. I need to factor x squared minus x minus 6, and I did that using a C method. So then you're right back to where you were. You say 3 and -2 are my critical values. I do a sign chart with -2 and 3. Since I only had 2 divider bars, I only had to test 1, 2, 3 sections on the sign chart. I built the sign chart like I did on the last 2 examples. Since it's less than or equal to, I did closed circles. And less than 0 means negative results. So I've shaded this part of the number line. And I just said bracket -2 to 3. Let's work somewhere you have to factor first. All right, here's one, and it's already written in the correct format as far as everything on the left, 0 on the right. So we have to start by factoring because this is not in factored form. So I noticed that there's no GCF and there's 3 terms. So I'm thinking we got to do the AC method. Well, AC is 2 times -30. 2 times negative 30 is negative 60. So I'm going to start looking at my options, okay? So let's see here. I need it to add up to 7. So 1 and negative 60, or negative 1 and positive 60, are going to give me 59. 2 and 30, whether it's negative 2 and positive 30, that's the difference is 28 or negative 28. Let's see, 3 and 20, the difference would be negative 17. So I'm getting closer, but I'm not there. 4 and negative 15, the difference would be negative 11 or positive 11 if I move the negative over here. So 5 goes in 12 times. Oh, look here. 5 and 12. If I made it negative 5 and positive 12, these would add up to positive 7. So now I know I need to say 2x squared minus 5x plus 12x minus 30. Of course, if you'd prefer to write right here plus 12 minus 5, you know that that's okay. So I'm going to get my scratch work out of the way. So let's see here. I've got x, 2x minus 5. Bring down your plus. I think 6 goes into both of those. And it better be 2x minus 5. So that's 2x squared, that checks, minus 5x, that checks. 12x, yes, minus 30, yes. So now I'm going to say it's 2x minus 5 times x plus 6. And that's greater than 0. Yes, hard part's done. I've got it factored. So do you see that my critical values then are at x equals 5 over 2 and at negative 6. So negative 6 is definitely on the number line before 5 over 2. 5 over 2 is the same thing as 2.5, remember. Now, word to the wise. Anytime you change from negative to positive, 0 is an easy one to pick. 0 usually runs fast in your sign charts. I'm going to pick 10 and negative 10, okay? So here I go. Plug into the factored form of it, okay? So that would be, if I plug in negative 10, negative 20 minus 5, and negative 10 plus 6. So that result would be positive. When I plug in 0, it would be 0 minus 5 and 0 plus 6. And when I plug in this 10, it's 20 minus 5 and 10 plus 6. So I've done the work. Now I just need to go back up and say, regardless of what the question asks, this is the work. But now I need to look at my work and decide what's the answer. So I see a greater than 0, which means open circles. And greater than 0 specifically means positive results. So I see a positive here, and I see a positive here. Now I give my answer. So my answer is negative infinity to negative 6, union 5 halves to infinity. All right, here we are with a new polynomial. It's a quartic, so sign charts are absolutely necessary. I've got everything on one side, 0 on the other. I'm going to factor, and I look and go, yes, there's a GCF, so I'm going to pull it out first. And I said, yay, because now I've got 1x squared, and that means I can factor a little faster. So if it's 1x squared or 1x to the 4th, then I can skip all the AC steps and just go straight to the factored form. So let's see here. My AC is 1 times 5. And the only thing I can do is say either 1 times 5 or negative 1 times negative 5, right? Those would be my only options. Well, negative 1 plus a negative 5 gives me negative 6. So I can say x squared has to be x times x. 1's minus 1, 1's minus 5. Factoring's done. Sign chart time. And when you hit the sign chart, this is where you ought to start feeling like it's easier. So critical values at x equals, x squared gives me an answer of 0, x minus 1 gives me an answer of 1, and x minus 5 gives me an answer of 5. Hey, these are already in order. So 0, 1, and 5 on my number line. Remember, pause the recording or rewind if you need to, okay? Less than 0 is negative 10. Between 0 and a half, or 0 and 1, I could pick a half. Between 1 and 5, I could pick 2 or 3 or 4, or any decimal. Greater than 5, I'm just going to pick 10. I'm kind of predictable that way. So we plug into the factored form here. So negative 10 squared is positive. Negative 10 minus 1 is negative. Negative 10 minus 5 is negative. Two negatives make a positive when I multiply. 1/2 squared is positive. 1/2 minus 1 would be negative, and 1/2 minus 5 would be negative. So I've still got a positive. 3 squared is positive. 3 minus 1 is positive. 3 minus 5 is negative. That's new. That's a negative. 10 squared, 10 minus 1, 10 minus 5. All right, sign chart's done. Now go back and figure out answers. So it says less than, not less than or equal to, so open circles. And if it's less than 0, it's negative, so negative results. So my one and only answer is 1 to 5. All right, so now I'm going to show you how to deal with a little adversity in your problem. So if you lead with a negative, that is a super big no-no. But if it were me, instead of factoring it out, what I would do is say, let me multiply everything by a -1 in order to get rid of that. So -1 times negative x to the 4th is x to the 4th. -1 times 5 is -5. -1 times -4 is +4. But remember, if you multiply by a negative, you have to flip-flop the inequality. And then -1 times 0 is still 0. So that's going to feel like a better choice, okay? Now, I notice that there's no GCF. It's a trinomial, so I'm going to try AC factoring. So my A times C is 1 times 4. So I can do 1 and 4 or 2 and 2, or -1 and -4 and -2 and -2, right? So it looks like that I need the -1, -4 to add up to -5. Now remember, since this is a 1x to the 4th, I can shortcut and say, well, x to the 4th is x squared. And I just said -1, -4. So I'm going to erase this stuff and get it out of my way. Now I notice that that's a difference of squares, so I'm going to keep factoring. And this is a difference of squares, so I'm going to keep factoring. And now I've got all my linear factors, all right? So now I can go, okay, I'm ready for critical values. Do you see that the critical values are at -1, +1, -2, +2? So I'm going to build my sign chart. So I put the 4 in order on the number line. Since I've got 4 critical values, and that's going to be 4 dividing bars, I'm going to have to test 1, 2, 3, 4, 5 sections. So you know me, I'm going to pick -10 and 10 here. And where it switches from negative to positive, I'm going to say 0 falls in between. So what falls between 1 and 2? 1.5 or 1.5. And here, -1.5. Or you could do 1 1/3 or whatever, 1 3/4, whatever you want to do. All right, so we plug it into the most factored form that we got, okay? So -10 plus 1, -10 minus 1, -10 plus 2, -10 minus 2. An even number of negatives makes a positive. -1.5 plus 1's negative, but -1.5 minus 1's -2. -1.5 plus 2 is positive. -1.5 minus 2 is negative. 3 negatives, an odd number of negatives makes a negative. 0 plus 1, 0 minus 1, 0 plus 2, 0 minus 2. 2 negatives makes a positive. 1.5 plus 1, 1.5 minus 1 is positive, 1.5 plus 2 is positive, 1.5 minus 2 would be negative. So this looks like it's going to be an alternating. It's sort of your garden variety sign chart. 10 plus 1, 10 minus 1, 10 plus 2, 10 minus 2. So I've done the work. The sign chart is the sign chart regardless of the question being asked. But now go back to the question. And I notice it wants greater than or equal to 0. So I'm thinking closed circle, and greater than 0 means positive results. So I'm shading my positive. So I'm going to have to name 3 separate intervals. So I'm going to say negative infinity to -2 bracket. Can you see this part? Union, -1 to 1. Union, 2 to infinity. Whew, that was a bigger one. Okay, we have another cubic inequality. So this is the first one where we've had to rearrange things. So I'm going to start out by saying, well, you got to do x cubed minus 3x plus 3x squared minus 16x minus 48 is less than or equal to 0. So I see no GCF, and I see 1, 2, 3, 4 terms. So I bet you know we're grouping. So I'm going to have x squared, x plus 3. Bring down this minus sign. 16 does go into 48. Double check, x cubed, yes. 3x squared, yes. Negative 16x, yes. Negative 48, so everything's good. That gives us x plus 3 times x squared minus 16. And then, of course, I recognize that's a difference of squares. So I'm ready, now that I've got it completely factored, to name all my critical values. -3, -4, +4. All right, let's put them on the number line. I just have to switch these two, don't I? So I'm going to be predictable. -4 and 4, I'm going to put on the outer edges 10 and -10. You don't have to use those. It just happens to be my go-to. When I switch from negative to positive, I'm going to 0. So between -3 and -4, -3.5, -3.8, -3.5, -3 2/3, whatever you want to pick there. So I'm going to start plugging in. You plug into the most simplified form, which is the final form you got it to. So -10 plus 3, -10 plus 4, -10 minus 4. 3 negatives make a negative. -3.5 plus 3. -3.5 plus 4 would be positive, so I get a change there. -3.5 and a -4. 2 negatives make a positive. 0 plus 3. 0 plus 4. 0 minus 4. And then 10, 10, 10, you can see those quickly are positive, positive, positive. So my work's done. Now all I have to do is answer my question. So I see a less than or equal to, so I'm going straight to closed circles. Less than 0 means negatives, so negative results. Negative result. I see 2 intervals, so negative infinity to -4, that's with a bracket. Union. Bracket -3 to 4 bracket. Okay, there you go. One more. It's going to be a little harder, but that's it. All right, so we're about to do one last problem. This is going to be more of a humdinger. I want to remind you that your homework is a 1.13, and it's the worksheet you've already got. If you look on the back of your graphing worksheet from yesterday, it's down there about a third of the way down the back of the page. And so I've not left you room. Make sure you do those problems on notebook paper so you can show your sign charts and your factoring and all that stuff. Okay, so let's go ahead and solve this inequality. I think I just erased part of it. So I look at it and it's all where it's supposed to be with 0 on the right. So that part's good. So I'm thinking, okay, there's not a GCF. Oh no, there's 4 terms, but it is not going to group because my ratio here would be 4 to 1 on my numbers. My ratio here would be -11, or don't worry about the signs, but 11 to 6. Those are not the same ratio. Now, if it had been 4 to 1 and something like 20 to 5, 20 to 5 would reduce to 4 to 1, but that's not what you've got. Okay, so it's not going to group. What can you do? Do you remember that we learned the rational root test? Okay, so the rational root test says do all the factors of 6, your end term, over all the factors of 4, your lead term. So when I look at that, what all goes into 6? That would be 1 goes into 6, 2 goes into 6, 3 goes into 6, and 6 goes into 6. What goes into 4? 1, 2, and 4. So my list is going to be 1 over 1, 2 over 1, 3 over 1, and 6 over 1. So just 1, 2, 3, and 6. 1 over 2 is new. 2 over 2 is 1. It's already in the list. 3 over 2 is new. And 6 over 2 is 3. It's already in the list. So I've done 1 and 2. Now 1 over 4 is new. 2 over 4 is a half. It's in the list already. 3/4 is new. It's not in the list. 6 over 4 reduces to 3 over 2, and it's in the list already. So these are my choices, and it's plus or minus on all of them. So 1, 2, 3, 4, 5, 6, 7, 8. So I could potentially test 16 possibilities. Let's hope we find one sooner. So remember, how do you test them? So I'm going to put y1 equals 4x cubed plus x squared minus 11x plus 6 in my calculator. I've already entered that, okay? Now I'm going to go to my table setup and make sure it's set up. So remember, we want ask on the independent or the x's, dependent set for auto, that's your y's. Go to your table. So I need to plug in 1. Oh, 1 gave me a 0 right off the bat. Can you see it? So 1's going to work. Yay. Well, that was fast. Okay. So remember, what do you do with the 1? All right. So I am going to say, let me do 1 with synthetic division. So I need to take it into 4x cubed plus 1x squared minus 11x plus 6. Bring down the 4. 1 times 4 is 4. 1 plus 4 is 5. 1 times 5 is 5. Negative 11 plus 5 is negative 6. 1 times negative 6 is negative 6. Bring down 0 and box it in. Remember, that's your remainder, and we expected a remainder of 0 because we were saying 1's a solution. So remember, if 1 is a solution, x minus 1's a factor. My other factor is negative 6 is in your 1's, x's, x squareds. So 4x squared plus 5x minus 6. Not is equal to 0, but is less than 0. I about made a mistake there. So this is quadratic. I've got to see if it'll factor again. So let's see, my AC is 4 times negative 6, which is negative 24. And I'm immediately thinking, wait a minute, 8 and 3. So could you do positive 8 and negative 3, and that would add up to positive 5? I think you could. So let's see here. I'm going to have x minus 1, and then I have to have 4x squared plus 8x minus 3x minus 6 is less than 0. I'm going to erase this now that I know what I'm doing. So I can't shortcut because it's 4x squared, not 1x squared. So these give me a GCF of 4x times x plus 2. I have to bring down this minus sign. 3 goes into 3 and 6, and it better be x plus 2. Let me double check at this stage and make sure I've not messed up something. So 4x squared checks, plus 8x checks, minus 3x checks, minus 6 checks. So I've got x minus 1, x plus 2, 4x minus 3. Whoop, whoop. Done. That's the hard part. The hard part's getting it factored. Hopefully you realize the critical value inside chart part's not too hard now. So I've got critical values at x equals, this gives me 1, this gives me negative 2, this gives me 3/4. So let's see here. On my number line, I've got negative 2, and then 3/4, and then 1. So woo, those are close together. That's going to be a little difficult. And I'll adjust my camera. So negative 10 and 10, I'm going to do my usual there. From negative to positive, I'm going to put the 0 in. So this is 0.75 and this is 1. So how about like 0.85? That work for you? All right, so negative 10 minus 1, negative 10 plus 2. This would be negative 40 minus 3, 0 minus 1, 0 plus 2, 0 minus 3, 0.85 minus 1, 0.85 plus 2. Uh-oh. So this one, let me look. So I need to do 4 times 0.85. So 4 times 0.85, and then minus 3. I'm getting positive 0.4. So 1 negative. And then 10 minus 1, 10 plus 2, 40 plus 3. All right, guys. So remember, we always plug it into our most factored form right there, the last thing we did. Now I want less than 0. So open and negatives. So I'm saying negative infinity to negative 2, union, 3/4 to infinity. Whew, that was a big problem. I feel like we've done something pretty special there. All right, guys, good luck on the worksheet.